Hello everyone, Tutorly here, and in this video we will be covering trigonometry, specifically the primary trig functions. So, to start, the primary trig functions are sine, cosine, and tangent. Now, we can use these primary functions in a right triangle to be able to find out missing sides or missing angles, and that is what we're going to be covering today. So, if we had a right triangle like this, right? And let's say this angle we're going to call x. We want to find what this angle is. We can use one of the trigonometric functions based on what we're given in the triangle to find this out. And an easy way to remember how to know which function to use is an acronym called SOHCAHTOA. So it's SOH. Now, it's important to note that from this angle, you have three sides. This side is the hypotenuse. We know this, right? It's called the hypotenuse. Now, from this angle, this side is called the opposite side because it's opposite to the angle. And this side is the adjacent side because it's adjacent to this angle, right? But it's important to note that if you wanted to find the angle that was here, this would now become the opposite and this would now become the adjacent. But for this angle, this is the opposite, this is the adjacent, and this is the hypotenuse. Now, to figure out which function you're going to use, this acronym tells us this. So for sine, which is S, we do opposite over hypotenuse, or the length of the opposite side over the length of the hypotenuse side. For cosine, we do adjacent over hypotenuse, which means we take the adjacent side and divide that by the hypotenuse side. Finally, when we're using tangent, we do opposite over adjacent, which means we take the opposite side and divide that by the adjacent side, right? And you pick which function you're going to use based on what you're given information. So I'm going to say that this hypotenuse side is 5 and this opposite side is 4. I'm going to leave the adjacent side blank. So now based on this triangle, you know what the opposite side and the hypotenuse side is, but you don't know the adjacent. But you want to find this angle. So this tells us that we should use the sine function because we know the two variables that can help us get that answer. So then we can figure this out by doing sine of x is equal to 4 over 5. Right? Now we can rewrite this saying sine of x is equal to 0.8. Now what we do now is we want to isolate x, right? But to do this, we need to get rid of the sign, which is why we're going to multiply sine by the sine inverse. So just like how you would divide something to get rid of something that's multiplying, to get rid of the sign, you would do the inverse sign. And you can find this on your calculator. So we're going to multiply this by the inverse of sine to cancel this out. But we need to do the same here. This gives us that x is equal to 8 times inverse sine, or sorry, 0.8 times inverse sine, which comes out to 53 degrees, rounded. So now we know that x is equal to 53 degrees. And we got this by using the sine function. So it's a pretty simple formula and a procedure. Now we're going to use the cosine. So now let's say that I didn't have this side, but I did have this side. 3. So now I can use cos and say cos of x is equal to 3 over 5. And that means cos of x is equal to 0.6. Now that means now we multiply by the cos inverse on both sides, which you can find on your calculator. And doing this, 0.6 times the inverse of cos, we'll cross this out, gives us that x is equal to 53 degrees. So this shows you that it doesn't matter which function you use, as long as you use the correct, sides, you'll get the same answer. I'll show, I'll show one last example with tangent, but this time, let's say that the angle we want to find is the other angle. So I'm going to say, okay, so I'm going to say this is the angle we want to find now. And I'm going to say that this is 3 and this is 4. We don't know the side. So now we can use the tan function and say that tan of x is equal to opposite over adjacent. So opposite is 3 over adjacent, which is 4. So now tan of x is equal to 0.75. Multiply both sides by the inverse of tan. This gets crossed out, and this means that x is equal to 0.75 times the inverse of tan, which comes out to 37 degrees rounded. And just like that, we found this angle using the tan function. So this showcases how you can use the three primary trig functions to find out the angles, the missing angles of a right triangle. Now, we can also use it to find the missing side. So let's say, and I'm going to show one example of that. So let's say we had this triangle. Once again, we want to find this side. Sorry, once again, we have this angle now, right? So let's say now we have the value of this angle, and I'm going to say it is 45 degrees, this angle. And I'm going to say that this, I know this, this side here is 8. And I'm going to say this side is 6. But I don't know what the hypotenuse is, right? Actually, we don't need this. So yeah, so I have this angle here and this side here, and I want to find the hypotenuse, which we'll mark as x. To do this, we can use the same formula, where we can say sine of 45. Now, so now we have the angle, so we can say sine 45 is equal to opposite over hypotenuse. So 8 over x. So now what we can do is we can simplify this. So sine 45 comes out to being 0.707. And this is equal to 8 over x. Now we can multiply both sides by x, so you can say 0.707x is equal to 8. Now what we can do is divide both sides by 0.707. And by doing this gets crossed out. X is equal to 8 divided by 0.707, which comes out to 11.3, which means our hypotenuse here is equal to 11.3. So you can see here how I used the same formula and algebraically was able to rearrange the equation to find the missing side. And this works for any side with any trig function, given you have the sides and angles to find it out. So this concludes this video, and this video brought insight to how to use the primary trig functions to find missing angles and sides in a right triangle. So please contact me if you have any other questions, and with that, have a great day.